Good morning. This is the AP Calc video for section 4.6. We're looking at some logarithmic integrals, one of which we kind of know, and then the others which we don't yet know. So, real quick, reminder that these first two examples are just plain old power rule, the integral of 1 over u squared. You could rewrite it as u to the negative second, and then just raise the exponent by 1, divide the new exponent, becomes u to the negative 1 over negative 1 plus c. And then I rewrote it as negative 1 over u plus c. There's the first one. Second one, same thing. If it starts as 1 over root u, I could rewrite that as u to the negative 1/2. And then it's still raise the power by 1, divide by the new exponent. So it's u to the 1/2 over 1/2, which again simplifies to root u plus c. None of that's new. That's the power rule. And then, as I've already said, you need to be real careful with what if it just says 1 over u. If you're not careful, you'll rewrite, as I did here in the crossed out section. If you're not careful, you'll write that as u to the negative 1, and then you'll think, oh, I can raise the exponent by 1 and divide by the new exponent. But that ends up as u to the 0th over 0, which doesn't make any sense. So remember, that's the one where we're undoing our natural log derivative. So this rule at the bottom here, you might see that before, the antiderivative of 1 over u du is the natural log of the absolute value of u plus c. That's not new. What's only mildly new is using that antiderivative just with u substitution. So I've got a few quick examples of integrals, and you would not know just looking at it that it's going to end up as a natural log. Like it very easily could have been, although I'm telling you these won't be. It could end up as 1 over u squared. Then it would look like this first one, and it would not be a natural log antiderivative. But if it happens to end up as 1 over u, that's when it is. So, and this may or may not be. We'll see. So let's do a couple examples. First one is the integral of 1 over 4x minus 1. So I'm hoping you recognize that as a u substitution. Because if I were to call u 4x minus 1, when I rewrote that, it would end up as some sort of 1 over u, which I like. So I will let u equal 4x minus 1, and the derivative of that is just 4. And again, I'm trying to match stuff up here. This 4x minus 1 is just u. I've got this 1 dx. Down here in green, it says 4 dx. So I may divide both sides by 4 and write it as this, because that enables me to substitute that as 1 dx is now 1/4 du. And I think I can now rewrite this. This is the integral of 1 over u, and then the dx is 1/4 du. Remembering that I am going to move the constant 1/4 out front. And now this becomes an antiderivative I know. So this is 1/4 times the natural log of the absolute value of u plus c, but now we can't leave it like that. Replace u with what u is, which is 4x minus 1. So my final answer is 1/4 natural log absolute value of 4x minus 1 plus c. Fairly straightforward u substitution natural log integral. Okay, next example. That is the integral of 2x over x plus 1 squared dx. So what do I call u? I don't see something whose derivative is right there. But again, if I were to call u x plus 1, I would at least have a u squared in the bottom. That I kind of like. So let's start with that. U equals x plus 1. So the derivative of that is just dx. Now, a couple things going on here. As I start substituting, this x plus 1 is u. I need a couple things. I have a couple options here. I was just about to circle the 2 in the dx, or I can move the 2 out front first. It doesn't matter. I might just do this because I was about to do it. Let's call this, what do I call 2 dx? Well, you notice down here, lower left, it says dx. I want it to say 2 dx. So I'll call that 2 du equals 2 dx. So now this thing here is 2 du. But now you'll notice I have this. I'm going to run out of space here. I have this x that I have to still substitute for. So I still need to, I need to know to solve this for x. That will be what? X equals u minus 1. So that, I don't have room to draw it, but that is going to go in for that x. So you got to be careful rewriting this thing in terms of x. This becomes the integral of, let's see, the x in yellow became u plus 1. And then we have over u squared. And then that 2 dx became 2 du. So I got to be real careful, but I believe I rewrote that correctly in terms of u. Now, almost took a sip of the wrong coffee. Now we have to know from section 4.1 how to take an antiderivative like this. And this one you have to recognize I need to rewrite this. So let's separate this so I don't see where I am here. So this is now 2 times the integral of u over u squared plus 1 over u squared. I just distributed the divided by u squared. And I can rewrite this. This is 2. I'll leave the 2 way out there, and I'll worry about that later. This is the integral of, let's see, u over u squared becomes 1 over u plus integral, what is that, u to the negative second, I guess. Now you'll notice that I've got 2 integrals. One of them does turn out to be natural log. The first one, the second one's just a power rule. So this is 2 times this one's natural log of the absolute value of u, and then plus, I'll write this as u to the negative 1 over negative 1 plus c. I might clean this up. I could either leave the 2 way out front or distribute it. I'll leave it out front. This is the natural log of the absolute value of, remember, whatever u was what? X plus 1. And then this cleans up to minus 1 over x plus 1 plus c. So that really did turn out to be a natural log antiderivative, at least part of it was. So there's your second example. And then your third example is a definite integral. So it says the integral from 0 to 3 of x over x squared plus 1. All right. Well, if I call u the bottom, x squared plus 1, its derivative is 2x, which is almost what the top says. So I kind of like that, I think. So I'll call u x squared plus 1, which makes the derivative of that 2x dx. I look at that 2x dx, and up here it just says x dx. So that 2 is in my way here. So I'm going to multiply by half here. So that makes this x dx 1/2 du. And it makes this x squared plus 1 u. But now let's change my limits of integration. Let's find u of 0. That's 0 squared plus 1, which is 1. And u of 3, which is 3 squared plus 1, which is what, 10. So I think this becomes the integral now from, not from 0 to 3, but from 1 to 10 of 1/2. I think it's just 1 over u du. Make sure that looks good. 1 over u. Okay. Which I believe just turned out to be 1/2 natural log of the absolute value of u, evaluated from 1 to 10. Now remember, with these, because I changed the a and the b, I do not need to go back in terms of u here. I can just make this 1/2 ln of 10 minus, I tell you, I'll put the 1/2 up front there, minus the natural log of 1. The natural log of 1 is 0. This becomes 1/2 the natural log of 10. And there's nothing wrong with stopping there. Like I would stop there, but as far as what an answer choice might look like, you can of course make it a decimal. That's not my point. But remember that 1/2 out front, I could write this as natural log of 10 to the 1/2, which I could then write as a natural log of root 10. Not better or worse, just equivalent. So there's 3 examples of natural log antiderivatives. Okay, and then the second part of this lesson is learning the integrals of all 6 trig functions. And I say that, of course, we already know a couple of them. So here's the whole list. And I think these first 2 we knew. That the integral of sine, other than the negative sign, is just negative cosine. The integral of cosine is sine. These other 4 we did not know. And the good news is you do not need to prove these are true. Like we really could. Not the point. This is one of these lists you just kind of need to know. Just like originally you needed to know the derivatives of all 6 trig functions. Now I'm telling you, you need to know the integrals of all 6 trig functions. And then I just have one example to do with you here, and then your assignment has a few others. Oh, I lost the page here. Page 350, example. Okay, here it is. So let's do one example where we'll have to take an antiderivative of a trig function. So let's go here. And this one says, and I'm going to type this, make it easier. This will make us remember something from a prior chapter. Find the average value, not sure I'm typing that so big. The average value of f of x equals the tangent of x on the interval from 0 to pi over 4. 0, comma, and I'm just going to not have to type 0 to pi over 4. Okay, you need to remember the formula for the average value. So the average value was 1 over b minus a times integral from a to b of f of x dx. You need to remember that that's the formula for the average value. So remember graphically, if I drew a picture of this, this was how tall would the rectangle be that has the same area as the actual area. So now let's just start plugging over. This is 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 of the function was tangent of x dx. Well, this is 1 over pi over 4. Remember, 1 over a fraction is just the reciprocal of the fraction. This becomes 4 over pi. Now, the integral of the tangent of something is one of the things you just need to memorize. So this is times the negative natural log of the cosine. Negative natural log of the absolute value of the cosine of x. And it is that from 0 to pi over 4. And now this becomes 4 over pi. In a minute, we're going to need a calculator to get that for you. So we're going to just stop at whatever it is here. So, tell you what, this negative sign that's right here, I'm going to move it out front next to the out by there just to make that a little easier. So I'm going to erase this arrow now, but I'm going to make that makes my calculation a little easier. So now it's negative 4 over pi times the natural log of, make sure I wrote this right. Sorry, times the natural log of the absolute value of the cosine of pi over 4 minus the natural log of the cosine of 0. Well, I think I know the cosine of pi over 4 is root 2 over 2. And the cosine of 0 is what? So this becomes negative 4 over pi times the natural log of root 2 over 2 minus the natural log of 1 is 0, right? We say yes, it's just 0. So it's negative 4 over pi times the natural log of root 2 over 2, which you could decimalize if you had to. It does turn out to be approximately 0.441. Don't know that I need that or not, but okay. So there's just one example. Again, you need to be, for the moment, for this assignment, have access to these 6 trig intervals. You need to know, ultimately need to know them. Okay, so here's the homework assignment. It's the same list. I wrote it out twice. I'm not sure which of these lists you like better. The first one has some of them, but there's so many different scattered pieces. I wrote it out, just all the problems. So either one of those is fine. We'll make this due at the end of the day on Wednesday. Today is Monday. Tuesday won't see you all. Wednesday we'll do a live lesson. I think actually on the next section. We're almost done with chapter 4, which is good. So That's all I've got. I'll see some of you at the live lesson in 20 minutes. The rest of you, I will hopefully see at the live lesson. I'll see some of you bell one today. The rest of you, I hope to see Wednesday morning. All right, have a good day.